Good morning, class. This is Mr. Eggleston, and this is lesson 7.5, Forms of Quadratic Functions. This is for Algebra 1, and the learning targets of this is to understand each form of a quadratic equation reveals different features of the graph, such as the x and y intercepts, the vertex, and the transformations that occurred from the parent function. All right. Also, we'll learn to calculate the vertex of a quadratic function given its equation in standard form using the formula x equals opposite of b over 2a. That gives you the x value of the vertex, which is also the axis of symmetry. So this is the axis of symmetry. All right. Just be aware. Yeah, so you're going to use this a lot. This is kind of muy importante. And that's not showing up, so I'm not going to worry about. Then we're going to demonstrate that two different forms of quadratic equations are equivalent by multiplying. Binomials together. All right, so let's begin. All right, today we'll look at the function f of x is equal to x minus 4 times x plus 2. These are the factors, okay? Explain how you know that f is a quadratic function. Well, this goes to the definition of a quadratic function, which is the fact that it's the product of two linear factors. Okay? Find f of 0. All right, so to find f of 0, we plug 0 into the equation. So literally, f of 0 equals 0 minus 4. That's this term, where x is replaced with 0. And times 0 plus 2. Since you got zeros, that really is just negative 4 times 2. So f of 0 equals negative 8. So that gives us the point, the ordered pair 0, negative 8. What does this tell you about the graph of f? This is the y-intercept of the graph. Okay? In other words, you know for a fact that the graph will cross the y-axis at 0, negative 8. And that's always the case, not only for quadratics, for any equation. If you're looking for the y-intercept, you let x equals 0 and you evaluate the function. All right, now it says find f of 4 and f of negative 2. Okay, f of 4 equals 4 minus 4, 4 minus 4 times 4 plus 2. The main thing is you have 0 times 6, which is 0. So f of 4 makes this first factor right here 0, which makes the whole thing 0 because you're multiplying by 0. So f of 4 is 0. And then what is f of negative 2? Same idea. Replace x with negative 2. Which equals negative 6 times 0, because negative 2 plus 2 is 0, which equals 0. So that tells us that when you put negative 2 into this function, you get 0 back at you. Okay? What do these values tell you about the graph of f? Well, since the output equals 0 for both those values of x, 4 and -2 represent the x-intercepts. X-intercepts. That is, the x-intercept is when y equals 0. And that's always the case. If you're looking for the x-intercepts of any equation, you will let y equals 0 and solve for x. Okay? So how do these values relate to the original equation? Well, they relate by making one of the factors equal to 0. Okay? One of the factors equal to 0. And so now, what is the axis of symmetry of the graph of f? Since we know that the x-intercepts are at 4 and -2, okay, we know the x-intercepts equal 4 and -2. We know that the axis of symmetry is going to be right smack in the middle of between these two values of x. So what you do is, to find the axis of symmetry, the AOS, you're going to find the average of 4 and -2 and find the midpoint by adding them together and dividing by 2. So 4 plus a -2 is 2. 2 divided by 2 equals 1. So the axis of symmetry for the graph of f is x equals 1. And how do you know? Because x equals 1 is exactly in the middle of, or in the middle between x equals 4 and x equals -2. So we know the axis of symmetry is x equals 1. Find the vertex of f. Well, that's easy. Now that we got the x value of 1, to find the vertex, we just evaluate f at the axis of symmetry, the value of x, 1. So this is going to equal, according to our equation, it will be -4 and +2. It will be 1 minus 4, 1 plus 2, which equals -3, because 1 minus 4 is -3. 1 plus 2 is +3. It equals -9. So the vertex of f is an ordered pair. It's not just the y value. So the vertex of f is going to be, it's going to be 1, because that's the axis of symmetry, comma, -9. And that's the vertex. Okay? Use your work above to sketch the graph of f of x. Well, 1, -9 is right here. We know the axis of symmetry is this vertical line. We also know that the x-intercepts are 4 and -2. 4 and -2. And we know the y-intercept is f of 0 is negative 8. Okay. Now I just saw that my vertex is off by a little bit. Okay. It's there at 1, negative 9. So now we just connect the dots. Okay. And there's your parabola. So now they want you to write an equation for f of x in vertex form. Well, that's going to be basically f of x equals x minus 1 squared minus 9. All right, the vertex is 1, negative 9, and vertex form is of a quadratic is f of x equals x minus h squared plus k, where the vertex is at hk. We saw that in the previous lesson. And there is the equation of f of x in vertex form. All right, so what we saw here is that the vertex is at 1, negative 9, right? And you saw that the 1 is there, the negative 9 is there, and also that they're equal. Okay, that's for something different. So let's go back. Okay. So Sasha says that f of x can be written as f of x equals x squared minus 2x minus 8. Do you agree? So what they want you to do is to take the equation we have for f of x and rewrite it to expand, as they say, this squared. Remember, to multiply, that literally means x minus 1 times x minus 1. And to multiply binomials together, we use a box. So we put x minus 1 here and x minus 1 there. And then we fill in the box. This is a great way of multiplying until you can get used to it. Because once you do this enough, you'll be able to multiply x minus 1 times x minus 1 in your head. All right, so again, x times x is x squared. Negative 1 times x is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is 1. Combine like terms, right there, you got x squared minus 2x, because there's negative 1x here and negative 1x there. You add them, that's negative 2x plus 1. And then don't forget, we have this minus 9. So combining these two terms here, we get f of x by carrying out the multiplication, that this f of x can be written as x squared minus 2x. 1 minus 9 is minus 8. And there you go. Okay. And is it the same? Yes. They can be written like this. Yes, they can. I'm just going to say yes, they can. Okay? So, this is an equivalent statement. These two are equivalent. That's what that means. They are the same. Okay? And we showed it by doing the multiplication here. Okay? Find f of 0 using Sasha's equation. So f of 0 is literally put 0 in for x. So that becomes 0 squared minus 2 times 0 minus 8 gives us negative 8. So that gives us the ordered pair 0, negative 8. What do you notice? Negative 8 is the y-intercept. And so the y-intercept always occurs when x equals 0, just like the x-intercepts occur when y equals 0. So y-intercept is easiest to see in standard form. It also happens to be just simply the number at the back end. That is the y-intercept. Okay. All right. So here we go. The last little bit before I stop this video and start a new one. 7.5 forms of quadratic functions. Quadratics can be written in different but equivalent, fancy word for saying the same, but equivalent, the same, they mean the same thing, they are the same function, ways to reveal distinct properties. For example, the vertex form, well, it kind of tells you by its very name that if you write in vertex form, you can easily get what the vertex is at h comma k. All right. In intercept form, which is y equals 8 times x minus p times x minus q, where p and q are the x-intercepts, obviously you can easily see what the x-intercepts are from this form. The values of x that make y equal to 0. Standard form, y equals ax squared plus bx plus c, where c equals the y-intercept, and the vertex is x equals opposite of b over 2a. That's important. You need to know that. Okay. What's nice about this is you can easily see the y-intercept. All right. Notice all of these equations have a in front. A here, and a here. That is the stretching factor of the equation. Okay. A is the vertical stretch in all three forms. They are the same number. So if you know what A is from this form, it's going to be the same in this form, and it's the same as this number here. Okay. Show two equations are equivalent algebraically by expanding vertex and intercept form into standard form. So we would multiply this together to come up with this, or expand this like we did to come up with that. That's how you can tell if two quadratic functions are equivalent, are the same. All right, there you go. I hope that made sense. And